All right, today we're going to work on mixture problems, and I'm going to introduce you to the bucket method, and hopefully it'll be helpful to you. Mixture problems can be challenging because you basically have multiple variables that things are changing at the same time, and it's based on percent, which can be confusing for some people. So I'm going to give you an example of what a mixture problem looks like, and then I'll show you the bucket method, or the method that makes sense for most kids. All right, Natalie has 3 gallons of juice that's 25% watermelon. So that means that in her 3 gallons, there's stuff that's not watermelon and 25% is watermelon. Thomas adds 1 gallon of a different juice that's 40% watermelon. The question is, what percent of the new mixture is watermelon? So you can see that you've got percents in 2 different settings, and then you've got a total, and they're asking you for another percent. This is just one model of mixture problems. They come in all different flavors, but for right now, we're going to focus on this one. All right, so you have to remember that mixture problems are based on the simple idea of percent times whole equals part. So in our problem with Natalie and Thomas, we know that Natalie has some mixture that is 25% watermelon. We know that she has a total of, I believe, 3 gallons. Should probably go back up and double check that she had 3 gallons. Yeah, she had 3 gallons. So her whole is 3 gallons. That's what she has in total. So the part of her mixture that is basically watermelon would be 1/4 of 3, or 3/4 of a gallon. The idea being that 0.25 times 3 would give you 0.75, or 1/4 times 3 gives you 3/4 gallon. So over and over and over, you're going to be multiplying the percent times the whole to get the part that's basically pure watermelon. You'll hear me say that a couple of times. All right, so here come the buckets. So this is really the easiest way to work these problems because it structures it for you. So you're starting with Natalie's 25% watermelon. She has a total of 3 gallons. Here comes Thomas, and I believe he had 1 gallon, and I think it was 40%, although I'm going to go back up and double check. Yeah, he had 1 gallon that was 40% watermelon. And they want to know, what do we finish with? How much watermelon is there to finish with? Now, percents don't work like, hey, just add them together. You can't do 25% plus 40% and say, oh, it's 65%. That's not how percents work. So by putting them in these buckets where you can say, I started with 3 gallons, that was 25%. I added 1 more gallon, that was 40%. I can then know that I end up with 4 gallons total, but I don't really know what the percent is. Okay, I am going to create an equation based on that. So I know that 25%, or 0.25 of 3 gallons plus 0.4 times 1 gallon should give me X amount times 4 gallons. That's the equation I'm going to be working with in order to figure out what that percent is. And again, percents don't stack up. If you got 55% on the first test and 20% on the second test, it doesn't mean you now have a 75%. Main thing to always remember with percents. So we're going to take that equation and now solve it. So we have 0.25 times 3 plus 0.4 times 1 equals X times 4. Now, to start, I am going to have you clear the percents. I want you to do this every time when you're dealing with these mixture problems and percents. Multiply by 100. You'll notice I'll often do this before I even write the equation down. I'll do it sort of at the bucket stage. But here today, I'm going to just show you how to do it at this next step. So I end up with 25 times 3. Note that I only multiply the coefficient by 100. I don't multiply both the 0.25 and the 3. It's just the coefficient. When you multiply, you don't distribute. That's not how it works. There's no plus minus sign. So just multiply the coefficient. 100 times 0.4 is 40. I'm going to write this 1 here, although all of you are saying, what the heck is she doing? That doesn't mean anything, but I'm just holding on to it so it stays consistent. And 100 times x, okay, times 4. I'll stop with this crazy color coding in a second. I just want to make sure you all understand that when I distribute the 100, it is to coefficient, coefficient, and coefficient. So I end up with 75 plus 40 equals 100x times 4 is 400x. I now add these two together. Oops, somehow I flipped to that. And get 115 equals 400x. I'm about to find my percent. All I need to do is divide by 400. And of course, I didn't bring a calculator with me. So I'm just going to open my phone real quick and do it on there. So 115 divided by 400 will give you x equals 0.2875. If you're asked to give this as a percent, please move that decimal and tell me that she ends up with 28 3/4% watermelon. In order to change a percent to a decimal, you move it 2 places over, and then you have 0.75 left, which is 3/4. We're going to do a couple more of these. All right, here's another one. Alice orders a 16-ounce smoothie and requests that it be 32% peach puree. When she gets the drink, it is only 15% peach puree. How much peach puree will they have to put in to make it the way Alice likes it? So I'm, again, brought those handy-dandy buckets in, and I'm going to go ahead and fill in some of this stuff. What do we start with? She starts with 15%. How much does she start with? 16 ounces. We know that she wants it to be 32%, and we know that she's going to add some amount, we don't know how much, so we're going to write X here, of peach puree. What percent peach puree is the peach puree that they're adding? 100%. They're adding pure peach puree to the smoothie to make sure it gets peachy enough. She ends up with the original 16 ounces plus X. I now have an equation that I can write. I'm going to change all these percents to whole numbers by multiplying by 100 right in that very first step. So I'm going to end up with 15 times 16 plus 100 times X equals 32 times 16 plus X. Looking pretty good here. I'm looking for a shortcut here, and I was hoping I had one, but 32 and 15 and 100 don't have a similar, nothing goes in that's the same, so I'm going to have to just work it out with the long numbers. So 15 times 16 will give me 240 plus 100x is equal to, I'm going to distribute that 32, get 512, oh, I don't know what's going on there, get 512 plus 32x. I now have variables on both sides. I'm not nervous about that. I'm just going to quickly move the lower variable to the other side first. Minus 32x, which gives me 240. So I don't make a mistake in the arithmetic, plus 68x equals 512. I'm now going to subtract 240 from both sides. And get 272. 68x equals 272. Last step, divide by 68 on both sides. And I get 4. What does that mean? I go back up to my little table up here and say, what did I just find? Well, in looking at this, it seems I found that X right there. I found that she wants to add 4 ounces of pure peach puree. I don't know why I chose peach puree because it's hard to say over and over and over. There we go. All right, let's try another one of these. Avi loves his orange punch, 5% orange juice. So when he orders his orange punch, he just only wants it to be 5% orange juice. When he buys 1.5 liters from the store, it's 18% orange juice. He doesn't want it 18% orange juice. He wants it 5% orange juice. How much water will he have to add to get it the way he likes it? Same thing I just did a second ago. I'm going to start with the bucket, start, add, finish. I'm going to fill in what I know. So what are we starting with? 5%. What are we supposed to have it be? Oh, reverse that. We don't start with 5%. He wants 5%. Erase, erase, erase. We start with 18%. We start with 1.5 liters. He knows he's going to add water. Now, this is going to sound like a trick question, but I'm going to ask it anyway. What percent of the water is orange juice? That's right. The water is 0% orange juice. He's diluting it. He's taking the 18% and making it 5%. So he's going to add some amount of water. We don't know how much, so we're going to call it X. So he's going to start with 1.5. Let's reverse that so I get a decimal there in the middle, plus X. Once again, the equation will naturally fall out of here, but you're going to notice that I am going to start by multiplying that top row by 100 so that I'm only dealing with whole numbers. I don't like to drag decimals down here because I find that kids make mistakes all the time, but here it's just going to be 0 times X. Okay, so 18% gives me 18. 0 times 100 is still 0. 100 times 5% will give me 5. I prefer working with the whole numbers rather than taking the step before. If I multiply the beginning thing by 100, I've cleared the decimals to start. 18 times 1.5 is 27. And this is just going to cross out because it's times 0. And then 5 times 1.5 is only going to give me 7.5 plus 5x. I'm now going to subtract 7.5 from both sides. Which gives me 19.5. Divide by 5. And x equals 3.9. So again, I go back to my chart and I say, what did I just find? Oh, I know. I found how much water to add. So we need to add 3.9 liters of water in order to get the orange punch the way Avi likes to drink it. Okay. Joseph's lemonade stand uses cane sugar to sweeten his drinks. A 32-ounce cup of lemonade is 15% sugar. Tanvi likes her lemonade much sweeter. She requests the drink be 24% sugar. How many ounces of sugar must be added to Tanvi's cup? All right, I'm going to let you start by drawing out your buckets. I'm going to let you start by putting in whatever you know. Okay, let's fill some of this stuff in. We start with 15% sugar. We start with 32 ounces. We are going to add what? Sugar. We want that to create it, to make it more sugary. We want it to be 24%, not 15%. We don't know how much sugar we're adding, but we know we're adding pure sugar. If we're adding pure sugar, my percent at the top here has to be 100%. Once again, I have the equation fall right out of this first buckets. I'm going to start by clearing the decimals, and I end up with 15 times 32 plus 100 times x equals 24 times 32 plus x. Do some multiplication here. 32 times 15 will give me 480. Loves to flip me to some other form here. Plus 100x equals 24 times 32 will give me 768 plus 24x. Okay, I've got variables on both sides again. I am going to start by moving the lowest variable here, which would have to be this 24. So I'm going to start by moving that. I will subtract 24x from both sides. I end up with 480 plus 76x equals 768. Let's subtract 480 from both sides. And we get 76x equals, what did I subtract 480? 288. Divide by 76. And you get 3.789. Let's round that to 3.8. When in doubt, round to the tenths. 3.8 ounces of sugar. Always go back up, look at your chart and see what was I finding there. All right. Believe this to be our last question. Okay, I'm going to have you try this on your own and see if you get that answer.